Good morning, children. As I promised to all of you that we are going to revise chapter called matrix. So we'll start the definition of the matrix. A matrix is an ordered rectangular array of numbers or functions. The number or functions are called elements or entries of the matrix. Example, in front of you I had mentioned two examples. Example, A matrix is a matrix of having entries of numbers, and the matrix B having the entries as a function. Now we look into the order of matrix. A matrix having m rows and n columns is called a matrix of order m by n, where m indicates for number of rows and n indicates for number of columns. In general, matrix A can be represented as a square braces Aij of order m by n, where I is starting from 1 to m. It can be equal to 1 and equal to m. That means rows can be one number and it goes to m. And j is also from 1 to n. The j column can be of 1 and it goes to n, where I and j belongs to all natural number. Now we are going to look into how to construct a matrix of different order. Here we have an example. Construct a 3 by 2 matrix whose elements are given by Aij is equals to half of modulus of I minus 3j. Solution. In general, we have a matrix of 3 by 2 is given by a matrix A is A11, A12, A21, A22, A31, A32. Now we have Aij is equal to half of modulus of I minus 3j. With the help of this, in place of I, we'll put the value of I, and in place of j, I'll put the value of j and calculate all the entries of this matrix as I calculated over here. You can see A11 is equal to 1, A12 is equal to 5 by 2, A121 is equal to 1 by 2, A22 is equal to 2, A31 is equal to 0 and A32 is equal to 3 by 2. Hence, the required matrix is A is equal to 1, 5 by 2, 1 by 2, 2, 0, 3 by 2. So in this way we can construct a matrix of any order if its Aij is defined. Now we are going to look into types of matrices. There are different type of matrices we can see. These are as follows. First, column matrix. A matrix is said to be a column matrix if it has only one column. Example, in front of you, I have a matrix A, 0 root 3 minus 1, 1 by 2 of order 4 by 1. Or in general, we can write the matrix A is equal to, in the square braces, Aij of order m cross 1, where 1 indicates there is only one column. Row matrix. A matrix is said to be a row matrix if it has only one row. Example, if a matrix A is equal to minus 1 by 2, root 5, 2 and 3 of order 1 by 4. In a general, we can write A is equal to Aij of order 1 cross n, where we have 1 indicates for there is only one row. Square matrix. A matrix in which the number of rows are equal to the number of columns is said to be a square matrix. Example, matrix A is equal to 3 minus 1, 0, 3 by 2, 3 root 2, 1, 4, 3 minus 1. It is in a matrix of order 3 by 3. Or in general, we can write matrix A is equals to Aij of order m by n. Hence, the matrix which having the equal number of rows and equal number of column are called square matrix. Now we have a diagonal matrix. A square matrix is said to be a diagonal matrix if all its non-diagonal elements are 0. Very simple. So the example is in front of you. Here is the example. Matrix A is equals to minus 1.1, 0, 0, 0, 2, 0, 0, 0, 3. or in general we can write A is a matrix in square braces. Aij is equal to m cross of an order m cross m, where Aij is equal to 0 when I is not equal to 0. That means all non-diagonal elements are equal to 0, right? And it is very important, diagonal matrix must be a square matrix, then only it be a diagonal matrix. Now we have a scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Example we see over here, matrix C, whose diagonal elements all are equal. They are root 3, root 3, root 3. Or we can write matrix A is equal to, in the square braces, Aij of order m by n. It is very important to understand Aij is equal to 0 when I is not equal to j. That means all non-diagonal elements are 0. And Aij is equal to k some constant when I is equal to j. That means all the diagonal elements are constant and they are same. That is called scalar matrix. Now we have identity matrix, a square matrix in which elements in the diagonals are all 1 and rest all are 0. Example of matrix over A over here is 1 0 0 0 0 1 0 0 0 1, or we can define it as A is equal to matrix of entries Aij of order m by m. Of course it's a square matrix where Aij is equal to 0 when I is not equal to j, means all non-diagonal elements are equal to 0, and Aij is equal to 1. Aij is equal to 1 when I is equal to j. We can mention over here also it is order m by m. Now, zero matrix. A matrix is said to be a zero matrix if all its elements are 0. And of course, zero matrix is also must be a square matrix. That's very important. And if a matrix have only one element and that element is 0, then again it is a zero matrix. That is very important to understand. So these are the few different types of matrices. Now we have to understand equality of matrix. Two matrices, matrix A of the elements Aij, matrix B whose elements are Bij, are said to be equal if and only if they are of the same order. The first thing is very important to be equal matrix. The orders of those two matrices are same and each element of A is equal to the corresponding element of B. That is, Aij is equal to Bij for all I and j, means each and every corresponding element of the two matrices must be equal, then only matrices are equal. Now we can understand this equality of matrix with an example. We have an example. Find A, B, C and D from the following equation, and the equation is given over here. Matrix A, 2A plus B, A minus 2B, 5C minus D, 4C plus 3D. On the right hand side, 4 minus 3, 11, 24. We have to find out the value of A, B, C, D from this equation. So we go. So here we have a solution of this equation. By equality of two matrices, equating the corresponding elements, we get 2A plus B is equal to 4, 5C minus D is equal to 11, A minus 2B is equal to minus 3, 4C plus 3D is equal to 24. Now we'll solve these equations by linear pair of equation in two variable, which all of you know by elimination method, which you did in the 10th standard. We solve it out and we'll obtain the solution such that, which is visible over here, B is equal to 2, A is equal to 1, C is equal to 3 and D is equal to 4. Hence it's very important to understand, guys, by using the equality of two matrices, how can find the unknown quantities in the given in the two different matrices. So here A is equal to 1, B is equal to 2, C is equal to 3 and D is equal to 4. With this, today's topic is over, and now we all of you going to solve the exercise 3.1 with the help of these all content which I explained right now. These are matrices, different types of matrices and equality of matrices. We are going to solve the exercise 3.1. This is your task for the next class. Thank you very much. God bless you.